Unit 7, Lesson 4 and 5, Practice. Number 1, Evaluating powers of 10. On A, we have 10 to the 0 power. Anything to the 0 power is 1. 10 to the third power divided by 10 to the third power. Well, as we all know, anything divided by itself is going to be equal to 1. But if we use our exponents, we can prove it by saying 10 to the 3 minus 3 equals 10 to the 0 power, which is equal to 1. On the last one, we have no rules for addition of powers of 10. So we simply simplify them to their standard form. 10 squared is 100. 10 to the first power is 10. And 10 to the 0 power is 1. 100 plus 10 plus 1 is 111. Section 2 asks us to express the expression with a single power of 10. If we take our power of 10, our exponent rules, and we use them, we add the exponents for 3 plus 4 to give me 10 to the 7th over 10 to the 5th. Then we use the exponent rule for division, 7 minus 5, which gives us 10 to the second power. On D, doing the same thing, we add our exponents on the top, so we get 10 to the 15th power. On the bottom, we do the same, adding our exponents, 10 to the 10th power. And then to divide, we subtract 15 minus 10, which gives us 10 to the 5th power. For B, we have 10 to the 4th power times 10 to the 12th over 10 to the 7th. Well, I can't do anything with 10 to the 4th at this point, so we need to take care of the division of 10 to the 12th divided by 10 to the 7th. So, if we subtract 12 minus 7, we get 10 to the 5th. So we have 10 to the 4th times 10 to the 5th, which means we add our exponents, and we get 10 to the 9th power. Moving over to E, we have a power to a power on the top, and a power to the power on the bottom, and then we have a division problem. So if we multiply 5 times 2, we get 10 to the 10th power. On the bottom, we have 2 times 3, so we get 10 to the 6th power. And then we subtract our exponents for the division of a power of the same basis, and we get 10 minus 6, which is 10 to the 4th power. On the last one, we have the division problem raised to a power. So we take care of the division first. So we subtract the 5 minus the 3 from the 10 to the 5th and 10 to the 3rd power. And we raise that to the 4th power. Well, 5 minus 3 is 2. And 10 to the 2nd power raised to the 4th power. We multiply 2 times 4. We get 10 to the 8th power. Section 3 of this homework is applying the exponent rules again, in a word problem. The sun is roughly 10 to the 2nd times as wide as the earth, and the star KW Sagittarius is roughly 10 to the 5th power times as wide as the earth. About how many times as wide as the sun is KW Sagittarius? Explain how you know. Well, if KW Sagittarius is 10 to the 5th times the size of the width of the earth, and the sun is 10 to the 2nd times the width of the size of the earth, then canceling out the earth, we have 10 to the 5th to 10 to the 2nd, which means we're dividing, and we subtract our exponents. 10 to the 5th minus 10 to the 2nd gives us 10 to the 3rd power. 10 to the 3rd power is 1,000. Therefore, KW Sagittarius is 1,000 times as wide as the width of the sun. And you can see over here how I showed that process. If the sun is 100 times the earth's width, and KW Sagittarius is 100,000 times the width of the earth, then if we put the earth with each one of them, the width of the earth. We can cancel the E, the earth, with, and also we can cancel 100 out of each, the top and the bottom, which leaves us 1,000 times the width of the sun. Sun. On section 4, we're writing with a single exponent again. This time it's going to involve negative exponents. 1 over 10 is actually 10 to the negative 1 power. So if we have 1 over 10 to the third power, that is negative 1, negative 1, negative 1, which gives us 10 to the negative 3 power. If we take the 1 over 10 to the third and write it as a reciprocal, we get 10 to the negative third power as well. Here we have 1 over 10 to the 7th power. If we take the reciprocal, moving the power and the exponent to the top, we get 10 to the negative 7th power. This one, we have 1 over 10 to the 4th power inside the parentheses. And we have that raised to the 2nd power. Well, 1 to the 2nd power is simply 1. 10 to the 4th power squared, multiplying exponents, gives me 10 to the 8th power. When I have 1 over 10 to the 8th power and I move the 10 to the 8th power to the numerator, my exponent becomes the opposite, which means I get 10 to the negative 8th power. Simply writing the reciprocal with a negative exponent, or the opposite exponent. You can see here I did it a little differently. I did the negative 4 from 10 to the 1 over 10 to the 4th and made it already, took the reciprocal, making it 10 to the negative 4th power, raised to the 2nd power, and then I just multiplied the exponents, negative 4 times 2, which gives me negative 8. There are always multiple ways that you can solve these when you have a multitude of different exponent rules that are in the problem. On D, we have 1 over 10 to the 3rd power raised to the 3rd power. Here again, I could change this to 10 to the negative 3rd power, or I could simply multiply the 3 times the 3 and have 1 over 10 to the 9th power. When I take the reciprocal of 1 over 10 to the 9th power, I get 10 to the negative 9. Or if I multiply the negative 3 times the positive 3, I get 10 to the negative 9. Either way, the resulting solution is 10 to the negative 9th power. Here I have 10 to the 3rd power raised to the negative 2 power. Well, when I have piggybacked, or a power to a power, I multiply the exponents, I get 10 to the negative 6th power. If I wanted to write this with a positive exponent instead of a negative exponent, then I would take the reciprocal of 10 to the negative 6th power, which would move the 10 to the 6th power to the denominator, and would move the 1 to the numerator as a placeholder. On the final set, we have select all the following that are equivalent to 1/10,000th, or 1 over 10,000. Well, if I simplify that to exponential form, I get 1 over 10 to the 4th power, or 10 to the negative 4th power. So I'm going to simplify each of these and see if I can get them to be 10 to the negative 4th, or 1 over 10 to the 4th power. 10,000 to the negative 1. Well, 10,000 is 10 to the 4th power raised to the negative 1 power. 4 times negative 1 is negative 4, so that is 10 to the negative 4th power, which is what we're looking for. So A is equivalent. B, I have the negative 10,000. Well, that is just simply the negative of 10 to the 4th power. That has nothing to do with the positivity or negativity of my exponent. Therefore, negative 10 to the 4th power is not the same as 10 to the negative 4th power, and therefore B is not equivalent. C, 100 to the negative 2 power. Well, 100 is 10 squared. To the negative 2 power, we multiply the exponents. 2 times negative 2 is negative 4. So this is also 10 to the negative 4th power, so it is equivalent. You could also take this and do 100 raised to the negative 4th power. 100 raised to the negative 2 power, and gotten 10,000 to the negative 2 power, to the negative 1 power, and then taken its reciprocal. On D, 10 to the negative 4th power, of course, is already in the correct form, but in case you forgot, because there was a parentheses there, that's 10 to the 1st raised to the negative 4th power. 1 times negative 4 is still negative 4, so it is equivalent. And the last one is the opposite of 10 squared. Well, the opposite of 10 squared means negative 10 times negative 10. Well, negative 10 times negative 10 is simply 100, which would be 10 squared. So it is not equivalent.